gives an idea about the distribution of electrons in the S sub-energy level. This is an introductory part of this Pauli's exclusion principle. And in this principle, it is observed that it is impossible for any two electrons in the same atom. The statement of Pauli's exclusion principle states that it is impossible for any two electrons in the same atom to have all the four values of quantum number identical or similar. What is the statement of Pauli's exclusion principle? It is impossible for any two electrons in the same atom to have all the four quantum number values, that is n, principal, azimuthal, magnetic and spin, identical or similar. This is the statement of Pauli's exclusion principle. That is, it in simple words we can say that all the four quantum number values in the same of any two electrons in the same atom are not the same or not identical. This is the Pauli's exclusion principle, and which gives an idea about the distribution or filling of electrons in the S sub-energy level. The limitation of this Pauli's exclusion principle is that in Pauli's exclusion principle, distribution of incompletely filled P, D and F subshell is not explained. So that's why, in order to cover this limitation, or in order to remove this demerit or limitation of Pauli's exclusion principle, the scientist Hund's, that is Hund's rule of maximum multiplicity, gives an idea about the distribution of electrons in the incompletely filled P, D and F subshells, because the capacity of P subshell is of 6 electrons, the capacity of D subshell is of 10 electrons, and the capacity of F subshell is of 14 electrons. So the most perfection or the most accuracy is required in case of Hund's rule of maximum multiplicity, because number of electrons in P, D and F are a large number, and that's why as number of electrons increases in P, D and F subshell, number of orbitals also increases, and that's why the distribution of electrons in the subshell as well as orbitals of the respective subshells is nothing but the Hund's rule of maximum multiplicity. In simple words, the scientist Hund's gives the correct distribution of electrons in the incompletely filled sub-energy levels, that is P, D and F, or it also gives an idea or information about the distribution of electrons in the orbitals of the respective sub-energy levels. So consider, and this Hund's rule of maximum multiplicity can be explained on the basis by taking very simple examples of electronic configuration of nitrogen and electronic configuration of oxygen. So electronic configuration of nitrogen is nothing but the nitrogen is the 7th member of the periodic table. So electronic configuration of nitrogen is 1s2, 2s2, 2px1, 2py1 and 2pz1. On the basis of above principle, the electronic configuration of nitrogen can be written 1s2, 2s2, 2p3. This is the electronic configuration of nitrogen. But P subshell contains maximum 6 electrons, but in case of nitrogen, P subshell contains only 3 electrons. So there are 3 orbitals in P subshell. There are 3 orbitals in P subshell, that is 2px, 2py and 2pz. We know that the capacity of each orbital 2px, 2py, 2pz is nothing but is of 2 electrons respectively. But 2px, 2py and 2pz contains only a single electron. Fifth electron enters in 2px, sixth in 2py, and seventh electron enters in 2pz orbital. So 2px, 2py and 2pz atomic orbitals contains 1 electron each on the basis of Hund's rule of maximum multiplicity. At the same time, the electronic configuration of oxygen having atomic number 8 is nothing but 1s2, 2s2, 2px2, 2p4, 1s2, 2s2, 2p4. That is, orbital electronic configuration of oxygen is nothing but 1s2, 2s2, 2px2, 2py1 and 2pz1. So this shows that the 1s, 2s and 2px, 1s and 2s contains 2 electrons, while 2px atomic orbital contains 2 electrons, because 2px atomic orbital contains 2 electrons of opposite spin, and remaining 2 electrons are placed in 2py and 2pz atomic orbitals. So these electronic configurations of nitrogen and oxygen shows that electron remains in the same or identical orbit. Electron remains in the same orbit, that is 1s2, 2s2, 2px1, 2py1 and 2pz1. Box diagram electronic configuration is 1s2, 2s2, 2px1, 2py1 and 2pz1. Similarly, the electronic configuration of oxygen shows that 1s having atomic number 8, that is 1s2, 2s2, 2px2, 2py1 and 2pz1. So this 8th electron in case of oxygen, enters in the 2px orbital. So 2px, 1s, 2s and 2px orbital contains 2 electrons each, and the last 2 orbitals, that is 2py and 2pz, contains 1 electron each. It means that these electronic configurations shows that electron wants to remain isolated. Isolation of electron takes place in case of Hund's rule of maximum multiplicity. That is, according to Hund's rule of maximum multiplicity, 1s, 2s, in case of nitrogen, 1s, 2s atomic orbital contains 2 electrons each, and 2px, 2py, 2pz atomic orbital contains 1 electron each on the basis of Hund's rule of maximum multiplicity. So this shows that these 2 examples are sufficient to explain or to state Hund's rule of maximum multiplicity. So according to the statement of Hund's rule of maximum multiplicity, we can say that pairing of electrons in equal energy orbital, does not take place whenever available equal energy orbital contains 1 electron each. Or in simple words, electron enters in empty orbital before they pair with electrons of opposite spin is nothing but the statements of Hund's rule of maximum multiplicity. So this Hund's rule states that electron wants to remain isolated, and finally this particular electron gets paired with electron of opposite spin. At that time, Hund's rule of maximum multiplicity can be satisfied very easily. So this is all about Hund's rule of maximum multiplicity. the next article after Hund's rule of maximum multiplicity. That is Pauli's exclusion principle, Hund's rule, and then the third one is above principle. But initially, before giving the concept, to explain the concept of electronic configuration on the basis of above principle, it is very important, it is necessary to explain the postulates of Bohr's atomic theory. थोडं थांबता येते कधी लिहायचं आहे मला. So the Bohr's atomic theory, that is the postulates or assumptions of Bohr's atomic model or Bohr's atomic theory. So before giving an electronic configuration on the basis, electronic configurations of the elements on the basis of Bohr principle, we have to discuss the postulates of Bohr's atomic theory or Bohr's atomic model. Before explaining the postulates of Bohr's atomic theory, there are two important theories which are explained by two determined scientists, that is John Dalton and Rutherford. John Dalton's atomic theory, explains only external structure of atom. John Dalton's atomic theory, or postulates or assumptions of Dalton's atomic theory, explains the external structure of atom. After John Dalton, in order to remove this demerit or limitation of Dalton's atomic theory, that is to explain the external structure of atom, can be removed partially by the scientist Rutherford on the basis of bombardment of fast moving projectiles like alpha particle on gold plate or gold sheet. So this is all about Dalton and Rutherford. So Dalton's atomic theory explains only external structure of atom. But in order to remove all the difficulties of Dalton and Rutherford, Niels Bohr put forth his idea or put forth his explanation about the internal structure of atom. So Bohr's theory is the theory which gives the internal structure of atom perfectly. So what is the internal structure of atom, or what is the postulates of Bohr's atomic theory? So we can see these postulates of Bohr's atomic theory one by one initially. We know that each and every atom of an element contains a nucleus. And according to the definitions of atomic number and atomic mass number, we know that atomic number is nothing the number of protons present in the nucleus of an atom. So we know that on the basis of characteristics or the special features of subatomic particles like proton, neutron and electron, we observe that proton is the particle which is present in the nucleus of an atom, and this proton carries a unit positive charge. So as proton is present in the nucleus of an atom, the fact is explained by the scientist Bohr, that is, as protons are present in the nucleus of an atom, definitely nucleus carries, every atom carries a positively charged center, and finally he can say that this positively charged center is nothing but the nucleus of an atom. On the contrary, heavy and compact are the two words regarding, or the two verbs used regarding or in case of nucleus of an atom. So this heavy is the word which explains the presence of protons and neutrons in the nucleus of an atom. So as a nucleus of an atom contains protons and neutrons, it becomes heavy, and that's why word heavy is used for nucleus of an atom. Why it is called as compact in nature? Compactness explains the size of the nucleus. The size of the nucleus. The size of the nucleus. Size of the nucleus is nothing but 1 into 10 to the power minus 13 centimeters. The size of the nucleus is 1 into 10 to the power minus 13 centimeters. It means nucleus has a very, very, very small size, or nucleus is very small size, having a very small size, and this small size contains these protons and neutrons. Due to small area of the nucleus and presence of protons and neutrons, nucleus of an atom becomes compact in nature. Due to presence of protons and neutrons in this nucleus of an atom, it becomes heavy, and that's why due to presence of protons in the nucleus, it becomes positively charged. So every nucleus, every atom consists of a nucleus which is heavy, compact and positively charged. So the center of an atom which is heavy, compact and positively charged in nature is called a nucleus of an atom. This is the first point regarding the Bohr's atomic theory. The second one, in order to balance the charge or in order to give the stability to the nucleus, same negatively charged particles are revolving around the nucleus. So, negatively charged particles which are revolving around the nucleus are none other than electrons. So, each and every electron carries a unit negative charge, that is -1 charge on the electron. So, these electrons are revolving around the nucleus in a fixed circular path, that is K main shell contains 2, L main shell, that is second one, contains 8, M main shell contains 18 electrons, and so on. So fixed circular path around the nucleus in which electrons are revolving or electron revolves is called an orbit. In simple words, electrons are revolving around the nucleus in a fixed circular path, and this fixed circular path around nucleus in which electron revolves is called an orbit. This is the second point regarding Bohr's atomic theory. The third point, initially, the research in case of elements is less or small in size, and that's why initially these orbits are named by or denoted by the integer numbers 1, 2, 3, 4, and so on. So that initially these orbits are named by the integer numbers, integer numbers n is equal to 1, 2, 3, and 4 respectively. Initially, these orbits are denoted by integer number 1, 2, 3, and 4 respectively. But these orbits have different capacity to accommodate the electrons. As we mentioned before, these integer numbers are then represented by the block letters, that is 1 is replaced by K, 2 is replaced by L, 3 is replaced by M, and 4 is replaced by N. So these integer numbers are converted into block letters, and that's why these orbits are denoted by block letters K, L, M, and N respectively. K, L, M, and N respectively. So the capacity of these orbits or these main energy levels K, L, M, and N are calculated by the formula number of electrons present in the main energy level is equal to 2n square, where n is equal to 1, 2, 3, 4, and so on. So 1, 2, 3, 4, and so on, the value of n. So we can calculate by putting the value of n is equal to 1, we can calculate number of electrons present in the K main energy level, and that is equal to 1. So when we put n is equal to 2, the 2 square, that is 4, 4 multiplied by 2, that is equal to 8. So 8, L contains maximum 8 electrons. Similarly, when we put n is equal to 3, 3 square means 9, 9 multiplied by 2, that is 18. So M main shell contains 18 electrons. At the same time, when n is equal to 4, 4 square, that is 16, 16 multiplied by 2, that is equal to 32. So these main energy levels contains a maximum capacity to accommodate, or main energy levels K, L, M, and N contains number of electrons equal to 2, 8, 18, and 32 respectively. So this is the fifth and sixth point regarding the Bohr postulates of Bohr's atomic theory. The seventh one, that is distance and the energy. Distance and energy. So K main shell contains 2 electrons. So the energy or number of electrons are less in number. So energy of K main shell is minimum or least as compared to P, D and as compared to L, M and N respectively. So number of electrons in case of second main shell, that is N is equal to 2, that is nothing but L main shell which contains 8 electrons. So energy of 8 electrons is greater than energy of 2 electrons, and the distance between the nucleus and energy level increases. So N is equal to 3, number of electrons present is equal to 18, N is equal to 4, that is in the fourth main shell, that is N, it contains number of electrons is equal to 32. So as we move away from the nucleus, the energy associated with the energy level increases. The energy associated with the energy level increases. It means that energy of the energy level is directly proportional to the distance between the nucleus and outermost electron. This is the conclusion about distance and energy. The last point regarding this is that these orbits are called main energy levels or main shells. These orbits are called energy levels. Energy levels. These orbits are called energy levels. These orbits are called energy levels because each orbit differs from each other. K contains 2 electrons, L contains 8 electrons, M contains 18 electrons and N contains 32 electrons. Initially at the center there is nucleus. There is a distance, sufficient distance between K and L, K and L and M and M and N. So distance between the nucleus and outermost electron increases as we move away from the nucleus. So number of electrons in the main energy level also increases. So increase in number of electrons indicates increase in energy. So these orbits have a characteristic energy that is different from each other, hence these orbits are called energy levels because each orbit contains different number of electrons. Different number of electrons indicates that there should be a different energy associated with the orbit. Hence these orbits having different energies, hence called energy levels. So this is all about the postulates of Bohr's atomic theory.